Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over part 2 of our AP Calculus multiple choice practice. We're going to be focusing on differentiation techniques. So let's go ahead and take a look at the first problem in this installment. So here it reads, the functions f and g are differentiable. For all x, f composed with g of x is equal to x, and g composed with f of x is equal to x. If f of 3 is equal to 8 and f prime of 3 is equal to 9, what are the values of g of 8 and g prime of 8? So this is a situation where we're basically going to use the chain rule to solve this problem. Okay? If you take a look at the problem given here, we know what f of 3 is and f prime of 3. So basically, that's a hint that we should start with the f differentiation and then use these pieces to create the clues that we need to find g of 8 and g prime of 8. Okay, so before we get started, let's review the chain rule real quick. So the chain rule, if you have a composite function f of g of x and you want to find the derivative of this function, the derivative of f of g of x is equal to f prime of g of x. That's the derivative of the outer function evaluated at the inner function times the derivative of the inner function. Okay, and if we have it reversed, if we wanted to find the derivative of g of f of x, it's basically the same thing but just in reverse order. So it's going to be g prime of f of x times f prime of x. Okay. All right. So let's take a look at this one, the g of f of x. Since we have f of x here and f prime of x, and we know what f of 3 and f prime of 3 are, so we have g of f of x is equal to x. So what are we going to do here? We're going to differentiate both sides of this equation. So differentiate that and differentiate this. On the left side, we will apply the chain rule. Okay, so it's going to be g prime of f, let me do that again, g prime of f of x times f prime of x. All right, and then on the right side, what is the derivative of x? It's just 1. Applying the power rule, this is x to the 0, which is just 1. Okay, now we know f of 3 and f prime of 3. Okay, so if we can just substitute those values in here, let's write a remark. Since f of 3 is equal to 8 and f prime of 3 is equal to 9, basically we're looking for the derivative of g of f of x at x equals 3. We can plug it in here. So that's going to give us g prime of f of 3 times f prime of 3 is equal to 1. How do we know that? Well, this equation tells us that the left side of this equation is always equal to 1. So regardless of what x is, we'll always have 1. All right? Okay, so let's see. F of 3 is 8 and f prime of 3 is 9. We can plug those values in here. So we are going to have g prime of 8, okay, equals g prime of 8 times, instead of f prime of 3, we're going to have 9 times 9 equals 1. Okay, so this can help us find what g prime of 8 is. So to accomplish that, we just simply divide both sides by 9. And then we have g prime of 8 is equal to 1 over 9. Okay, so with this information, we can narrow down our options. Is either option B or E. We can drop off A, C, D. Okay, so how do we know what g of 8 is? how can we determine what g of 8 is? Now, what we're simply going to do here is take a look at the second situation and apply the same procedure and then see if we can determine what g of 8 is. So we know that f of g of x is what? F of g of x is equal to x. Okay, we were given that information in the problem also, right there. Where is it? Okay, over here. So we're going to differentiate both sides again using the chain rule. So we'll find the derivative of the left side and the derivative of the right side. When we differentiate the left side using the chain rule, we're going to have f prime of g of x times g prime of x. Okay? And then the derivative of x is just 1. Now, let's go ahead and find, we can plug in 8 for the two x's here. So basically the derivative of f of g of x at x equals 8. So we're going to have f prime of g of 8 times g prime of 8, which is equal to 1. But we know that g prime of 8 is 1/9 from our previous answer. So since g prime of 8 is equal to 1/9 from this result right here, we can rewrite this equation as f prime of g of 8 is I'm sorry, times 1/9 is equal to 1. Okay, and then multiply both sides by 9, of course. Multiply both sides by 9. Multiply by 9. Multiply by 9. And then we're going to have f prime of g of 8 is equal to 9. Okay, so let's go back here. What do we know f prime of, let's see, we know that f prime of something is equal to 8. 9, I'm sorry, f prime of 3 is equal to 9. So f prime of 3 is equal to 9. Let's write that down. Since f prime of 3 is equal to 9, I'm writing down 3. Since f prime of 3 is equal to 9, then we can create an equation. F prime of 3 is equal to 9. Then f prime of g of 8 has to be equal to f prime of 3. Okay? So f prime of g of 8 has to be equal to f prime of 3. What does this follow? This follows that, you see, what is the input of f prime? G of 8 is equal to 3 because that's the argument for the derivative of f. So that simply follows that g of 8 is equal to 3. Okay, so g prime of 8 is 1/9 and g of 8 is equal to 3. Our answer is option letter E. All right, let's take a look at the second problem. So we have to find dy dx when y is equal to x sine x. So what are we going to do here? This is a product of two functions, so we're going to have to use the product rule. Okay, remember what the product rule is. uv prime is equal to vu prime plus uv prime, or you can say uv prime plus vu prime. It doesn't matter since addition commutes. All right. So let's see. This is our u, and this is our v. Okay. So let's find the derivative. dy dx. The y dx is v, which is sine x, times u prime x prime, derivative of x, so that's vu prime plus u, which is x, times v prime sine x prime. Okay? All right, so let's use our differentiation skills here to finish this problem off. dy dx is equal to sine x times derivative of x is just 1, plus x times the derivative of sine x. So what is the derivative of sine x? Recall that the derivative of sine x is negative cosine. I'm sorry, it's positive cosine x. Why am I switching the sign? So derivative of sine is cosine, but the derivative of cosine is negative sine. So derivative of sine is cosine x. All right, and then if we simplify that, we have dy dx equals sine x plus x cosine x. All right, so let's see what is our answer. Our answer is option letter B. If you messed up the sign like I almost did earlier, you get this, fall into this trap right here. So don't forget the derivative of sine is positive cosine. All right, let's move on to the next problem. All right, so for this problem, it says if f of x is equal to 7x minus 3 plus ln x, then f prime of x equals. So here we have to find the derivative and evaluate it at a point, okay? So let's see, f of x is equal to 7x minus 3 plus ln x. The derivative, f prime of x, derivative of 7x is just 7, derivative of 3 is 0, plus the derivative of the natural logarithm of x is 1 over x. All right, so let's evaluate the derivative at x equals 1. Simply input 1 into your x's. We have 7 plus 1 over 1. 7 plus 1, your answer is 8. Answer is option letter E. All right, let's take a look at the next problem. This one is assessing our ability to accurately apply the chain rule again. So if y equals the quantity x to the third minus cosine x to the fifth, then y prime is. So let's see. Since this is a composition of two functions, I'm going to write it as f of g of x equals x to the third minus cosine x to the fifth. Okay? All right, let's decompose this function. We just have two functions here, so it shouldn't be too complicated. The outer function or the parent function is f of x, and f of x is x to the fifth power. Okay? So that leaves us with the inner function as x to the third um, minus cosine x. So the inner function is x to the third, or inner function is g of x. Let's not forget that. X to the third minus cosine x. All right, so let's find the derivative of f. F prime of x is equal to 5x to the fourth, and g prime of x is equal to 3x squared. Derivative of cosine is negative sine times this minus becomes plus sine x. Okay, now remember your chain rule. F of g of x, the derivative of that is the derivative of the outer function evaluated at the inner function times the derivative of the inner function. Okay, so what we'll simply do here is evaluate the outer function at the inner function, so plug in g of x into x here, times g prime of x. Okay, so let's go ahead and do that. Our derivative, y prime, is going to be f prime of g of x. So just simply plug in this quantity into the x here. So we have 5 times the quantity x to the third minus cosine x raised to the fourth power, okay, times g prime of x, which is 3x squared plus sine x. And there goes your derivative. Answer is option letter E. All right, let's take a look at the next problem. It says let f be the function defined by f of x equals the square root of the absolute value of x for all x. Which of the following statements is true? Okay, so is f continuous but not differentiable? F is differentiable at 2. F is not continuous at x equals 2. The limit as x approaches 2 of the function is not 0. X equals 2 is a vertical asymptote of the graph of f. So concerning, if you take a look at this function, um, are there any vertical asymptotes? What creates vertical asymptotes? In most cases, if you have a denominator function, You do not have any denominator situation here. So you do not have a vertical asymptote in this graph. You can just eliminate that based on the fact that you do not have any denominator polynomial expression. Okay, so continuity and differentiability. Let's talk about deal with the continuity first. So is f continuous? Is f of x continuous? So what is this question using calculus notation? Using calculus notation, the question that we're asking is the limit as x approaches 2 from the left of the function equal to the value of the function, and is that equal to the limit as x approaches 2 from the right of the function? Now, if this function is continuous, that automatically means that the limit exists, okay? It might be 0, we don't know yet. Okay, so let's go ahead and do this. So this function, you can think of it, this is a piecewise defined function. So for this one, we can think of it as f of x equals square root of negative x minus 2 when x is less than 0. I'm sorry, when x is less than 2. And um, the other side, square root of positive x minus 2 when x is greater than 2. All right? So we have something happening at 2. It could be a corner or a cusp, something like that. We don't know yet. Anyway, but what we're looking for is the limit. So this is from the left and this is from the right. All right? So we are looking for continuity at 2. Is f of x continuous at x equals 2? Let's be more specific. Okay? So that's what this expression is saying. Okay, so for the left-hand limit, this is simply going to be the limit as x approaches 2 from the left of the square root of negative x minus 2. Okay, now since we're already approaching from the left, we don't need to carry this directionality here. We just take the negative piece. And then f of 2 simply involves plugging 2 into this function, the square root of 2, absolute value of 2 minus 2. Is that equal to the limit as x approaches 2 from the right? Just involves taking the positive. Okay, so remember this is 2 from the left, and this business here is 2 from the right. So it's going to be x minus 2. Okay, all right, let's go ahead and simplify that. Here we are going to have the limit as x approaches 2 of square root of, if you just plug in, oh, here, let's do this. We can just plug in 2 into this function right here. Evaluate this limit by substitution. So we have the square root of negative 2 minus 2. And then here we have the square root of the absolute value of 0. And then here we have the square root of 2 minus 2 by direct substitution again. And then 2 minus 2 is 0. The opposite of 0 is 0. Square root of 0 equals the square root of 0 in the middle is just 0. And then here you have square root of 0 also. You have 0 equals 0 equals 0. The left-hand side and the right-hand limits are the same, which means the limit exists and is equal to 0. And the value of the function is defined at 0. I mean at 2, and the value is 0. So since all these three are the same number, that means that f of x is continuous at x equals 2. Okay, that means the limit exists. So that tells us that option letter D is false. Okay, is f of x continuous at x equals 2? Yes. So it says f of x is not continuous. This is false. Now, since f of x is continuous, does that automatically imply differentiability? If a function is continuous, does that automatically mean it is differentiable? The answer is no. Okay, so let's go ahead and check to see if this function is differentiable at x equals 2. So the question we're asking ourselves is f prime of 2 defined? how do we know if f prime of 2 is defined or not? Well, that's pretty straightforward. All you simply do is differentiate the function and evaluate it at x equals 2. If your answer is defined, then it's differentiable. If it's not undefined, then it is not differentiable, okay? So let's go ahead and find the derivative of this function. I'm going to be using two rules here. Remember that the derivative the absolute value of x is equal to x over the absolute value of x, and the derivative of the square root of x is equal to 1 over 2 rad x, okay? I'm going to be using the chain rule, combination of these two formulas to find the derivative of this function, all right? So f prime of x, you're going to take the derivative of the outer function, which is 1 over 2 root u, and u is absolute value of x minus 2, so 1 over 2 root u, so root absolute value of x minus 2, times the derivative of the inner function u is absolute value of x minus 2. Using this formula here, we're going to have x minus 2 over the absolute value of x minus 2. So we have x minus 2 divided by the absolute value of x minus 2. All right. And you can, of course, you can make this pretty, is not necessary, but let me just go ahead and make this look pretty. So f prime of x is equal to x minus 2 divided by, now square root of x minus 2 is x minus 2 raised to the 1 half, and this is 1 or 2 over 2. So this becomes 2 times the absolute value of x minus 2 raised to the 1 half plus 1, which is 3 over 2. Okay? So we want to find f prime of 2. We want to know is this defined or not. We'll simply plug in 2 into this function. So we have 2 minus 2 divided by 2 times the absolute value of 2 minus 2 raised to the 3 over 2. We can clearly see that we have a big problem here. We have 0 over 0, which is undefined. So what does this mean? It means that f is not differentiable at 2. F is not differentiable at 2 because, as we can see, the derivative at 2 is undefined. So let's see. F is continuous but not differentiable at x equals 2. Voila, our answer is option letter A. All right, let's take a look at the next problem. It says if f of x equals the square root of x squared minus 4 and g of x equals 3x minus 2, then the derivative of f of g of x at x equals 3 is, so we are looking for the derivative of a composite function evaluated at a specific x value. So we're going to be using the chain rule here again, and then evaluating at a point. So we have f of g of x. So what is the derivative of f of g of x? Let's just refresh our memory again, real quick. F of g of x prime is equal to the derivative of the outer function f evaluated at the inner function g of x times g prime of x. Okay? Now, let's see. The outer function f of x is the square root of x squared minus 4. Let's find the derivative. I'm going to cut corners here. F prime of x using the chain rule is going to give us 1 over 2 rad x squared minus 4 times the derivative of the inner function, which is simply 2x. Okay? And then g of x is 3x minus 2. G prime of x is the derivative of that, which is just 3. Okay? So what we're going to do is apply this result to this problem, to this formula right here. So to do that, we're going to take g and plug it into f prime. Okay, so take g and plug it into the x's here, that one, and that one, and then multiplied by g prime of x. That's just the chain rule. Okay, so the derivative of this function, f of g of x prime is going to be, oh, we can divide these two twos so we don't just carry it out over and over again. So divide those two twos. We're going to have, instead of x, plug the g of x into that x. We'll have 3x minus 2 divided by, let's make that a little bit uh, longer so we can take it in. Divided by the square root. The square root of, instead of x squared, we just plug g in there. So it's going to be 3x minus 2 quantity square minus 4. So this is f prime of g of x, okay? Multiplied by what? G prime of x, which is just 3. We are asked to find the derivative at x equals 3, so we'll simply plug in 3 into this function here. So f of g of 3 prime just involves plugging in 3. Now, we don't have to do any cosmetics here. We're evaluating, so just leave it like this. Don't simplify or don't waste your time doing anything like that. We'll just simply uh, plug it in and simplify, okay? So plug in 3. 3 times 3 minus 2 divided by the square root of 3 times 3 minus 2 square minus 4 times 3. Okay? So this is just basic arithmetic we're going to be doing here. So we have 3 times 3 is 9. 9 minus 2 is 7. 7 times 3 is 21. 21 over the square root of 3 times 3 is 9 minus 2 is 7. 7 squared is 49 minus 4. So that yields 21 over rad 45. And then we can simplify that. That gives us 21 over, this is 9 times 5, so it's 3 rad 5. And then 3 goes into 21 7 times, 7 over rad 5. That's your final answer. Option letter A. All right, let's take a look at the last problem in this part. It says let f of x equals the quantity 2x plus 1 raised to the third power, and let g be the inverse function of f. Given that f of 0 equals 1, what is the value of g prime of 1, the derivative of g evaluated at 1? So let's go ahead and find the inverse of this function first. So let's say y is equal to 2x plus 1 to the third. So if I want to find the inverse of this function, g, I'll simply switch x and y and solve for y. Okay? So let's call this x. X equals 2 times the inverse, that's going to be g plus 1 raised to the third power. Remember, g is the inverse, okay? So let's go ahead and solve this, just like a basic algebraic equation for g. So what we'll do is take the cube root of both sides of our equation. So that resolves that cube there. And then we have 2g plus 1 equals, let me write this as a power, okay? X to the 1/3, so it's easy to apply the power rule later on. Subtract 1 from both sides. Still trying to isolate g. 2g equals x to the 1/3 minus 1. And then we can go ahead and divide both sides by 2. Okay? Divide everything by 2. So we have g. G equals 1/2 x to the 1/3 minus 1/2. All right? The problem asks us to evaluate the derivative of g at x equals something. Don't remember what it is. X equals 1. Good. So to do that, first thing we'll do is find the derivative of g. Okay? So g prime of x, using the power rule here, is 1/2 times 1/3 x to the, subtract 1 from 1/3, you have negative 2/3 minus 0. Okay, derivative of 1/2 is 0. Okay, I don't need to simplify and waste my time. I just plug in 1 for x and then go from there, okay? So 1/2 times 1/3 times 1 raised to the negative 2/3. Simplify that. G prime of 1 is equal to 1 over 6. Our final answer is option letter D. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found this tutorial helpful or beneficial, go ahead and give us a thumbs up. We'll appreciate it. Don't forget to subscribe to our channel for other cool tutorials such as this. If you have any questions, just feel free to include it in the comment section below, and we'll be glad to address it as soon as possible. More clips can be found on math.serve.com. Go ahead and check it out under AP Calculus. Thanks again for watching, and have a wonderful